This meeting is being recorded.
In problem 21 from chapter 10, we are asked to predict the major product or products for each reaction listed below. So we're reminded to consider if any chiral centers are being generated. And then we're asked to draw all expected stereoisomers if there are chiral centers. So let's take a look at our molecules below here. So we have molecules A through D, and each of these has the same set of reagents. So we'll review what those are, and then we should expect the same reaction, the same mechanism to take place. So the reagent HBr indicates that H and Br will be added across the double bond, the pi bond of our alkene here. And in the presence, so that's the top reagent, in the presence of peroxide, the bottom arrow reagent here, that would generate an anti-Markovnikov addition. So if you recall, usually with Markovnikov, we have hydrogens go where hydrogens are more present. So in this case, our hydrogen will go where there's less hydrogens, and then our bromine will be added to this side here. So let's take a look at what happens. Right, we'll remove our double bond. We've added that hydrogen to the site of less substitution, and we would add our bromine over here. But we need to pay attention. Once that double bond is broken, we have created a chiral center. So one of our stereoisomers would have that methyl group on a wedge, and then we could draw our other stereoisomer here, which would have that methyl group on a dash. So for A, we would produce a racemic mixture of these two enantiomers. So racemic enantiomers. And these are our two stereoisomers. Let's take a look at B and see what happens there. So we have the same reaction that we expect here. So we have our pi bond that was broken. We would install hydrogen over here. Bromine will go on the less substituted spot. So what happens when we install the bromine here, after the pi bond is broken, we do not create a chiral center here. So there's no chiral centers to worry about. So we only have this single product for when substrate B reacts with HBr in the presence of peroxide. Let's take a look at our alkene with or alkene listed as C here. So same process again. So let's draw our carbon skeleton here after that double bond is broken. You might notice that we will have, again, a pair of enantiomers that will be created. So we will add our bromine over here on the double bond. But this site here is a chiral center. So we're going to have one of these methyl groups would be on a wedge here, and then we'll change this methyl group over here to be on a dash. So these will be our two products, again, a racemic mixture of enantiomers. So let's take a look at D and see if we see another set of enantiomers, or if we have chiral centers created, or if we already have them present. So it looks like we do not have any chiral centers present in our alkene starting material. So we will add hydrogen to this side. Actually, rather, we're going to add our bromine, to that side there. Hydrogen will go over here to the least substituted position, or the more highly substituted position. Bromine will go over here. So let's see how that will look. And indeed, we will create a chiral center when we brominate. So we'll put this bromine on a wedge, and then we'll draw this other product here with bromine on a dash. So these are all the expected stereoisomers or single products, as with B, for these reactions.